I'm Ali Shaikh. I run product for Graphiant. And let's first start out with who we are, what we do, and we'll get into the technical stuff because I know this audience loves to get into the technical weeds as quickly as possible. Graphiant is a network as a service company focused on solving connectivity problems in the wide area space. A lot of us come from prior experiences with the Ciscos, the Junipers, the Viptelas, the Versas, and so on and so on and so on. And for us, there was a moment of realization during the pandemic around, okay, connectivity needs are changing, and this is an opportunity to create a new company. And we're very, very grateful to Tech Field Day. I mean, you hosted our very first session after we came out of stealth 1 year ago. And I'll be honest, right? The feedback we got was, this show is amazing. You haven't paid me to give a plug for you guys, but genuinely, like, it's been a year of a lot of positive feedback about how great this show is. So thank you again for having us. So there's a lot of stuff that we've built over the last year, but we'll still talk about the problems and some of the things that we've seen after we came out of stealth, right? So a year ago, we were in secret building stuff. We've now had a year of customers and deployments and a lot of experiences that we can now talk about. What started to happen? And let's talk a little bit about that, what led to creating Grafiant in a quick nutshell. A lot of us were at Cisco, Facebook, VMware. A lot of us were acquired through Viptela or VeloCloud into a lot of different organizations. I was part of the Viptela group that was absorbed into Cisco. Arsalan, who will join us shortly, he was at Meta. Were they still Facebook then? No, they had converted to Meta at that point. So we were in a lot of different places, and we were all locked down at home. And we were seeing this sudden shift of people working remotely, workloads moving all over the place. Everyone was trying to come up with, well, we need to connect this to that, and VPNs are hard, and everyone hates the VPN, and networking people are just crunched with config changes and change control and all of this kind of stuff. And even those of us on the overlay side and VPNs and SDWANs and stuff, we were like, no, there's got to be a better way to do this. And fundamentally, the kind of use cases that are showing up will need some kind of transformation. We see a lot of use cases start to emerge around edge compute, and I know that's been like a buzzwordy thing for a long, long time, but we actually started to see some real applications in the manufacturing and agriculture space, and a lot of them were saying, we're deploying things at the edge. We happen to be the first ones to do it, but we need a network for it. And then this year got really wild with all the Gen AI stuff. And a lot of the times I would say, we're just network. I'm not AI or anything. I'm not going to do any of that stuff. But everyone was, we're just churning out massive amounts of data. And our network is still too rigid. We need some kind of change. And so then we would talk about what are the actual options on the table. And you really don't have that many options if you boil it down. We still have MPLS VPNs, private network offerings from telcos and service providers that provide you a guaranteed connectivity model, and we've had that since the 90s when it was developed. And we originally developed it to deliver voice when we first rolled out unified communications, and we needed low latency queues and QoS and bearer traffic for voice and all the other things. We still have it. And we still have a lot of it. And it isn't going away because it still serves an important need. But the thing that it had was it was inflexible and the internet was not included. So then we spent the 2010s into the 2020s doing SD-WANs. We had so many different companies building lots of different overlay models so we could bring the internet in, but we ended up creating more tunnels on top of more tunnels. And so then it became the question of, yes, we've done a bunch of automations and we do things with Python, we've got Ansible playbooks and all these kinds of things. But our network, we haven't really changed the protocol layers. And if we're going to talk about making more arbitrary programmable networks, we need new protocol stacks. So that leads to Graphiant. And then we'll talk about what we're doing in the protocol layer. But first, let's draw on the specific protocol pieces that we had to think about.
Ali, I have a quick question. This is Tim Bertino.
Yeah.
I personally see a lot of parallels between SD-WAN and Graphiant's solution. Can you kind of get into what are some of the key differentiators between SD-WAN and what Graphiant's doing?
If I want to give you a one-line, almost like a tweetable answer, is the number
Hang on.
is the number of tunnels.
Okay.
I'll really boil it down to that. There's a lot more layers to it, but fundamentally, the point was we've got to get rid of these tunnels that we've bloated. With SD-WANs in general, with the overlay models, edge to hub, tunnel, you add a new circuit, more tunnels. You want more redundancy, more tunnels. You want to create a full mesh, more tunnels. You want to go to Zscaler, more tunnels. And to ultimately, a question was, SD-WAN has more or less become a tunnel management tool. How do you bring that down? How can I get the kind of end-to-end connectivity without having thousands of tunnels? That's the nutshell of it, right? If I start to go broader, we can talk about programmable protocols and talk about how things like segment routing and MPLS VPN capabilities should be accessible to an end consumer without having to understand segment routing, right? You can get much more elaborate about it, but that's really the heart of it. How do you make it operationally simple, reduce the number of tunnels?
Okay.
So to piggyback on his question, Grafian has no tunnels at all.
No, I wouldn't say it has no tunnels at all. Because, and this is funny, last year when I was here, we got into a fun conversation about encapsulation and tunnels. What is a tunnel? And it became the case of, and you'll appreciate this, right? From a tight coupling standpoint, when people talk about, is the encryption, data plane, and control plane tightly coupled? Or is it decoupled, right? A classical VPN, an IKE VPN, IP VPN, control plane, data plane, encryption plane, all tightly coupled. You establish IKE, you establish IPsec, you establish key exchange. You go to SD-WAN, we separate control and data, but the encryption layer is still tightly coupled. You have a tunnel, the encryption keys are peer-to-peer. What we've done is further decouple. Control plane separate, data plane separate, encryption plane separate. So you still have an end cap, so technically speaking, it's still a tunnel, but what it isn't is a decryption event at every hop. And that, funny enough, we're just going to talk about in 2 seconds. But it's the heart of the problem, right? If I make a one single sentence version of it, is state is the problem. How do you manage state? With MPLS VPNs, the problem is the state machine on the provider edge box. How many VRFs can it hold? How many customers can it hold? Anytime you need to make a change, it overloads the PE. You have to go in and change it all over again. It was one of the main reasons MPLS VPNs are so rigid. The telco is the only one who can touch it. You have to order it, do all of those kinds of things. And if we look back at what led from MPLS to SD-WANs in a way was ordering a VRF from a service provider is very expensive. So with SD-WANs, we're just like, let's give segmentation capabilities. That's not that expensive. But the problem was state machine on the provider edge box. Last year when we were here, a lot of people were like, well, is this going to disrupt the service providers? And we were like, it might. A year of our experience has now shown the service providers are one of the most vocal coming to us saying, we have massive problems maintaining a large operational footprint to handle all these PE boxes and all the configs that go on thousands of these boxes. If you're telling me in protocol layer that can go away, I want it. So it's been I've been proven wrong. I was very clear last year. I was like, the SPs will resist us. The SPs are not resisting us. It's been a very, very fun journey this last year. This has been the more interesting thing that we run into a lot of the time, which is with SD-WANs, we actually created and compounded the VRF problem. We've made it a VNF problem. We now spawn VMs inside colos, on bare metal, on AWS. We just spawn more and more VMs to terminate all the tunnels that we now need to manage. Even when you look at some of the other middle mile solutions, they're using their environments to allow you to spin up another vendor's VM in their environment. How much throughput can you get? How many tunnels you can terminate ends up becoming the question, right? And tunnel count is your big limiter, because the number of CPUs you can assign to a virtual machine that can handle tunnels is your limiter. And so that leads to creating a lot of bloat. And this turned into another experience over this last year. Was a lot of the companies we talked to, both the previous slide about provider edge state and NFVs turns into, we have a power problem. How many servers can I put? Because a data center has a megawatt rating, and I can't just install a new nuclear reactor to power all these things that I'm going to do. How do we get the power consumption down? And if my CPUs are just being burnt to terminate IPsec tunnels, that's a huge problem. Now, environmental sustainability is, arguable in different circles, but cost is cost, and electricity is a cost that you incur. So this has turned into quite a big conversation with a lot of customers. How do we reduce VMs for IPsec tunnels? And so then for the Grafian solution, what we needed to make sure we could do, it has to be a combination of technologies we've had before. People expect, like with MPLS, reliability, SLAs. They expect that it's going to be end-to-end private and has security capabilities. But then, like they start to experience with SD-WAN and the whole as-a-service model, I want to have consumption models to consume, pay as I go. I want to have the agility to scale up and down my consumption, not be tied to these software licenses or contracts that force me to pay for a network that I may or may not be using that way. I want to be able to dynamically change it. And it should be flexible. I shouldn't have to redesign my whole network because I had a merger event and I absorbed a company, or I have a whole new service rolling out, so a whole network has to be redesigned. And at the end of the day, that really is a question about protocols. Automation of an existing system doesn't change the existing system, but our protocols, and especially the networking folks, right? We love protocols. Our protocols are what have allowed us to turn what was a DARPA project into the thing that now runs the whole world. Protocols. They're scalable, they're dynamic, they can adapt as needed. You don't need people to do those kinds of things. Build the intelligence into the protocols. So at Graphiant, this is what became the solution premise. We're going to separate control data encryption planes. The control plane will be off-path. We want to have a data plane, a high-performance data plane, and have end-to-end encryption. Almost like it behaves like the signal protocol, right? You're end-to-end encrypted, but there's no intermediate breakages. There's no termination of a tunnel. It gets always messy when I say this. There is no decryption event in transit. All right? The data is encrypted end-to-end, just like you expect with your phone. iMessage is encrypted end-to-end. You don't expect it to be decrypted somewhere inside the telco space. With SD-WANs, you don't have a choice. Wherever that tunnel boundary is, a decryption event is happening. That needs to go away. Privacy and security will be expected, right? So with security services, a baseline level of UTM capabilities has to be there, but the future of security is changing constantly. And this is where I'm going to say something that will be a little bit interesting. I don't think SASE is a meaningful thing. I'm going to say that trying to combine all of network and security into one thing is not going to work out. Because one thing, the network layer, is about being as efficient and stateless and headless as possible. We got to move a packet from point A to point B. Security is the opposite. I need to look at everything and stop this packet before it can go anywhere else. I don't know how that's a philosophically different things. So a lot of the times what we end up saying is, in the SASE, let the network people handle the A, because we know how that works, and you do whatever your security stuff is, and it'll all work out. And then goes without saying, the world we live in, got to be cost effective. Got to be cost effective when it comes to electricity, compute, you can't just waste CPU cycles on terminating IPsec tunnels. That has to be a better way to do that. So what did we build? And so let's talk about what are some of the things that we've built in order to make these things possible. The first layer right above is the Grafian cloud piece. We needed to build a management infrastructure for this entire infrastructure. We leveraged Microsoft Azure for that. And this was going to be a cloud-native microservices architecture environment to do all of these kinds of things. And the vision there...
So just real quick, I want to interrupt real quick.
Absolutely, go.
This is Nick Baraglio, virtually. So you've mentioned, I don't know, like 9 or 10 times, IPsec termination. This is implying to me, and you can correct me if I'm wrong, that you're not using that. So are you going to get into what encryption models you are actually using on the back end of this?
Yes. So when we get into like the packet walks, you'll see what the headers actually look like. We are still using the IPsec suite. We're just using it differently because we still have AES 256, but the way we use ESP versus the authentication header, the different suites within IPsec, we're using them differently. So strictly speaking, if you were to inspect the traffic on the wire, it would look standards-based. From a network layer, it will look standards-based, but the techniques and how we're using it is what separates us.
Okay, so that answers my next question. Is this WireGuard? And it sounds like no.
No, it is not WireGuard.
Okay, so it is actually a form of IPsec that you've customized. And my second question, I guess third question, since you answered my second one, is actually go ahead. I'll bring it up later.
All righty. Now, from a management standpoint, we're looking at a lot of things. We still have so much SNMP and other kinds of things. It's just a case of, all right, are we approaching a point where we can start moving to protobufs and streaming telemetry and actually set up native Kafka integrations, those kinds of things. We still have to support SNMP. We still have to support everything. And that's the trickiest part of being networking versus any other area. We don't get to walk away from a technology once it's fallen out of fashion. If it's somewhere in the infrastructure, we still have to support it. Some things as far back as AS400 mainframes, still somewhere in the networks. We have to support all of it. The network has to support everything. From an edge-to-edge standpoint, we wanted to deliver simplified edges. We didn't want to build hardware, so we certify a bunch of different platforms. I think we looked at some different manufacturers that build, purpose-built CPEs and UCPEs and edges and things like that. And then a lot of the times over the last year or so, a lot of customers were, can I run it on Dell? We like to buy Dell. I'm like, sure, you can run it on Dell. There's no problem. The uniqueness of what our solution comes out to be is the stateless core and the gateway infrastructure.
And that's the question I had. We talk about less tunnels. Are we creating our tunnels to that stateless core?
Yes.
And that's how they're being distributed? Okay.
Yes. So what that ends up creating, and this is where when you see the packet walk, that'll be particularly interesting. Your edge to core relationship is in strict sense the tunnel that allows you to connect over any kind of transport into this core. But the data does not get decrypted in the core. There's no routes in the core. There's no VRFs in the core. This is a IP-free, this is essentially a label-switched environment.
So from an edge perspective, it doesn't look like I have a full mesh to all my other edges. Okay.
Jordan Villarreal, quick question. So once you're in the core, you said there's no routing in the core.
It's label switching.
It's all label switching. So is that per customer I'm defining that, or you guys are handling that on the back end?
We handle all of it on the back end. So from the end customer standpoint, their experience is as if you were using an SDWAN style product or an MPLS style product. I have an edge, it arrives at my site, I connect the circuit, I set up my policies, either globally or device by device, whatever you may want to do.
Sure.
As from your viewpoint as an end customer, it's connecting into Ashburn or Seattle or Dallas or wherever your nearest core is, but you're connected to all of your sites as a result.
So let's say I'm a really green company, because we touched on that a little bit earlier about making sure that we're being eco-friendly. Can we make decisions in there in terms of picking the route that has the least carbon footprint or the smallest carbon footprint?
That is very, so strictly speaking, and this is funny, thank you for that.
Yeah.
What we've gotten the last year or so is a lot of national security oriented questions around, can we choose the path, which countries it touches? And so we've gotten a lot of that, but that is, I mean, the capability is fundamentally the same. Policy language allows us to do that.
Right.
Because the metadata in the labels allows us to essentially identify, this is dark fiber, this is private, this is US approved, but now from an eco standpoint, certainly. It's not something we've done so far,
Right.
But it's entirely possible to do so. That's
Okay.
actually very cool. We should just...
Yeah, and that's something that I've heard in the DNS space, like when we start talking about globally load balancing your DNS and where you're landing within content providers, like we want to go to data centers that aren't...
That are more sustainable.
Yeah, they're more sustainable, or they're not being hit as heavy right now, or things like that.
Absolutely.
Interesting.
Can you say
I want to pull on that a little bit more. So two things. One, you mentioned national security-based stuff. So that implies to me that you are at least entertaining working with the U.S. federal government, which begs the question, can I terminate these on without IPv4?
So, yes, this is all dual stack. And strictly speaking, the core itself uses a form of SRv6. So we are actually...
Oh, that was going to be my next question. I want to get into the label stack bits a little bit. If you're not going to do it later, I want to start teasing apart the mechanics of the label switching that you're doing.
Absolutely.
All right.
So in terms of picking your routes, is it something that you negotiate as part of your contract with Grafian? Is that something that's within the control of the user? Like if I'm like green hospital, I want to be, I want green routes. I don't want, dirty routes. Do I get to like stay in
this is not a... Right. The whole point of this piece. So where we are right now in the stages that we're in, a lot of people are currently first doing like an apples to apples comparison of, can I write the same policy that is written based on loss, latency, jitter, those usual metrics. Policy control around these things is what's in the works. So we haven't really done the green piece, but that would be...
You've done the
exactly.
DoD
So
stuff,
for those kinds of things are coming in around, don't take these countries. We want to control the path. That is in the end user control. This is not a contractual thing. This is a policy that you can control from the portal, because it's meant to be that way. For us, the whole concept here becomes, this is a state-free environment where there are labels assigned to different kinds of transports. You don't have to know in depth, right? They're easy to consume around, these are the regions, these are the cities, these are the kind of providers we use. I think last time when I was here, I mentioned we used Zayo, Telia, Hurricane Electric, Packet Fabric, Equinix, Megaport, AT&T, Verizon, Etisalat, British Telecom, Vodafone, Telefon. Like that's we're able to multiplex across all of them.
Ali, one more question on the course. So, what level of visibility do the customers have in case of outages, brownouts, capacity of that stateless core?
In terms of how much visibility we're trying to build out different layers to this, because just the amount of data is a lot, and what we want to show should be meaningful. So we're trying to replicate kind of the model that AWS and Azure have done very well as well. Here's a global status page. Here is the latency loss grid map.
Okay.
From there, then we can go deeper and deeper. There's obviously going to be ongoing requests, and we're going to be building them as we go. But yes, we want to give you that visibility. The long-term goal, if you think about where this leads us, is if the core is programmable via API, via dashboard, and you have visibility into the metrics in terms of what it is and how it's behaving, first we'll start with us as engineers deciding what's the best designs we want. Then eventually, now I'm going to use a buzzwordy thing, AI should be able to program it, right? It's not a full reconfiguration event. Eventually, then we can have SDKs around applications. When you build them cloud natively, you can actually make an API call that the application itself tells the network, this is the characteristics I want. Now, this is entering into the realm of futuristic and a little craziness, but it's if you think about philosophically, right? Why do we always, as network people, get blamed for not supporting the application? It's like, here's an API. You app developers, when you're building the app, if you want to transact with the network, this is the API. And the network will do these things. And if you break something, you as the application owner have the responsibility. I, as the network owner, do not. I give you an API. But that's a world I think we may be able to get to, but we'll see.
But real fast, so you're saying you have that API in place for the product now,
We have it for ourselves right now. We haven't opened up.
but it's not to us, if you will.
For you, there is, but right now, we're layering on these different policy controls, right? It's could you program this? Yes, you can. Right now, the logic we've opened up so that we could meet the RFP requirements is loss, latency, jitter, path characteristics, quality of experience, quality of service. The next wave, in order to meet some of these national security requirements that have come up, telco requirements, and now I think this has been a fantastic idea around creating environmental and sustainable pathways. We can define those, saying, well, this carrier in this region has a better environmental footprint.
At some point, can you talk to maybe how you're determining where you're at geographically or what your intentions are for that?
Yes.
Sorry, I forgot. I'm breaking loose. I apologize.
This is going to be the fun part, right? So
I'm sure we're blowing up your order of operations.
it always happens. It all works out. And this is where it's the heart of it, right? It's from a geographically. Last year when we came out of stealth, we were all US based. This year onwards, we start expanding internationally. Our focus has been Europe. So from a US standpoint, we covered all the Equinix. We're primarily based out of Equinix. So US Equinix. In Europe, it's London, Frankfurt, mainland Europe, nothing in Eastern Europe, nothing in countries we're not allowed to go to. Asia Pacific, Middle East is again in the works as well. We're seeing a lot of activity in Abu Dhabi, Dubai, and Singapore, and Tokyo. So those are the kind of pathways. We'll essentially end up having a global ring with all these different providers. Equinix, Digital Realty being the data center locations for us, carriers being literally all the carriers in those regions. And I think that image, all right. I know time check is always fun. All right. So we talked a lot about the core, and the whole point of how this core operates was take out IP, use label switching, have metadata available to be able to extend in this environment. Again, right, take benefits from the segment routing capabilities without having to teach all of my end users segment routing. Encryption end-to-end, programmability, fundamentally, you should have agency over the paths that are taken. And then, yeah, fundamentally, when people would always ask me, it's like, well, why can't someone else do this? I'm like, it's not just automation and Python. You have to change things in the protocol stack. All right. I'll pause here for a second. We'll cover the use cases quickly, and then we'll start going into a deeper tech dive into the stack.
I have just a quick question here as
Yes.
well. It's Bruno Wallman. You're showing the edge as part of the architecture, which is obvious. The edge needs to be there. What do those edge devices look like? Is it all virtualized on as VMs, or are there appliances? Does it depend on your throughput and bandwidth? What does that look like?
The short version of the answer is yes to all of that. Is it virtual machines? Yes, but we don't see massive amounts of virtual machine model deployment right now, just because we're trying to reduce the overall VM footprint. We still have some customers who use VMs. We particularly see on the appliance side, people use appliances from, I mentioned Dell, but there's Lanner, there's a few others. is an x86 based solution, so it can run on anything that has an Intel processor. And so Intel processor, and it has to have a TPM 2.0 certified cryptographic key store. As long as it has those two things, it will work.
Okay, so the edge solution is running Graphiant software. It's
Yeah.
not just it's not creating direct IPsec tunnels to the core. It's running Graphiant software that's doing that for you.
That is correct.
Okay.
Yes.
So quick follow-up to that. You mentioned it needs to be an Intel processor. Given power requirements, is there any plan for like ARM64 support or anything like that?
Yes, there are plans for that. We've
Okay.
been talking to a particular manufacturer that builds even lower power footprint devices. Again, everything is sort of business driven right now, and the
Yep.
highest demand we see is on the Intel processor side right now. But yes,
Yep. Makes total sense. Just thought given the
Yep.
given the talk about power consumption, that was probably something you were going to mention at some point anyway.
absolutely.
One more question about the architecture there. It's, it seems easy to hook up to if you're already internet facing. What about higher security networks, OT networks, and, the utility space? Do you have any solutions for that? Not necessarily air gap network, because then
Right.
that would be impossible to speak, but is there some sort of proxy solution, or do you have any solutions for a higher?
The models that we're working for that particular environment is because we're already in the Equinix points and at the peering points, the things that we're looking with at least one of the carriers is around how to establish NNI type infrastructure, which means if it doesn't even touch the internet, can it come over an entire private pathway into the Grafian core infrastructure? So we have the designs for that, but this is where we're working through with carriers around what the implementation timeline looks like for something like that.